All right, so in chapter 4, we're going to be talking about inverse trigonometric functions. So kind of the first order of business here is going to be to develop an inverse function for our sine, cosine, and tangents. So if we go back and we remember, say for example, the graph of sine looks like this, right? And we remember back in chapter 1 when we talked about finding inverses, one way we can do that is just by swapping the x and y coordinates for all the points. So if I do that for my graph of sine, I get something that looks like that. Any issues we see with that? Yeah, just swap the x and y coordinates for all the points on the first graph. But look at the look at that second graph. Does anything stick out to you with regard to that, Landon?
I don't know if you already said it, but like you don't have the full like range of points from the other graph.
Sure you do. You know, like this point right here is just like that point right there, right? Like any point you've taken, is that second graph a function? No, why not? Fails a vertical line test, right? So that's the issue right now that we have. Everybody's okay with that? So what we want to do then is we're going to say, okay, well, let's restrict the domain for y equals sine x. So when I swap the x and y coordinates, I end up with something that's a function. So what I want to do is I want to make sure that none of my y coordinates get repeated. So I'm going to pick some section of this graph where no y coordinates are repeated, but all the possible y values get used. So really I just need to take from extrema to the next extrema. Now the standard place where we do that is from like negative pi over 2 to positive pi over 2 is usually where we make that restriction, just because it includes 0 and that's kind of nice. So when I do that, I get this graph. Everybody's okay with what I've done? So I've just chopped off, you know, and just take one little section of that previous graph. And the reason I want to do that is because when I make my inverse, Hi, Domenico. I now have something that is a function, right? Everybody's okay with that idea? So now that we have something that is a function, this is something that we can now program into a calculator to do stuff with, right? If before, when we had like multiple outputs, the calculator can't handle that. But if our inverse has now only one output, like we do for a function, we're in good shape. So we're going to name this function sine inverse, and the notation we use is sine, and then we write the -1 exponent there of x. The domain for this function is -1 to +1. And the range for this function is -π/2 to +π/2. Everybody's okay with that idea? So for sine inverse, what we're going to do is we're going to input a value between -1 and +1. And what the sine inverse function is going to do is give back to us an angle measure between -π/2 and +π/2. Right? So one little issue here. Why, if I look at this range of values, we think back to like our unit circle. -π/2 is down here, and +π/2 is right here. So it's our sine inverse function can only output angles that are in Q1 or Q2, quadrant 1 or quadrant 4, excuse me. Right? Well, what if I'm looking for an angle that was over here in quadrant 2 or quadrant 3? We can still find those values, but the calculator is not going to ever output them for us. So the rest of what we're doing today is going to be talking about how we can use the sine inverse function that we've developed to find angle measures that may not lie inside of -π/2 to +π/2. Is that okay with everybody? Okay. So let's look at so for cosine and tangent, we would do a similar process. I don't want to go through the process again for each of them because it's kind of like the same thing. I'm just going to write down the inverses and make note of their domains and ranges. And then we're going to just probably do a boatload of examples of using these things from here on out. Or for the rest of the class anyways, we're just going to do some examples. Okay? Landon?
Those points you just gave are the base ones, like, right? They're always
So these aren't points, these are the domains and ranges. So these are sets of values. So yeah, if you think about sine, cosine, right? The biggest value that sine or cosine can have is negative or is positive 1, and the smallest is negative 1. So the inputs to the sine or cosine inverse are going to have to be a value between negative 1 and positive 1. And then they're going to output an angle measure, right? Now, because of how we restricted the domains to make a function, the outputs, the ranges for sine inverse and cosine inverse are different. Just because of the graphs are different shaped, right? That's kind of what you're asking?
Yeah,
Okay. I just want to make sure that we're, that I'm clarifying. And again, this is the first time you're seeing this or doing this, so it's okay to have lots of questions and clarifications and make sure, the stuff that I'm writing down, we understand, right? Because there's a lot of symbols and a lot of notation, and a lot of vocabulary, and if we're not quite sure, certainly asking, and we can talk some more about it, make sure we're all on the same page. You know what I mean? Okay, so let's do some examples. So if I do sine inverse of negative 1/2, and that's just my direction, the expectation would be just to go to your calculator, input sine a negative 1 or sine inverse of negative 1/2, press enter. Should probably make sure our calculator is in radian mode. And that's it. So negative 0.524 or so. So if you have your calculator with you and you want to try that out on your own, you're welcome to do that. I just typed it into my calculator exactly as it looked on my sheet of paper. The sine inverse command is secant, and then the sine button. So that's one way. Everybody's okay with that? What if I ask for the exact value of sine inverse of negative 1/2? When I see the word exact here, I know I'm going to have to use the unit circle. So let's pull that and put that in here so we can refer to it. Okay. So what I'm going to do is I'm going to look for, or I remember on the unit circle, the x-coordinates are values for cosine theta, and the y-coordinate are values for sine theta. So I'm going to go look on my unit circle for places where the y-coordinate is negative 1. So I see one here and one there. Everybody's okay with that? Now, I know that the range for sine inverse is quadrants 1 and 4. So the one that I'm looking for is the one in quadrant 4. Everybody's okay with that? And the angle measure for that, or that has sine a negative 1/2, is 11 pi over 6. Everybody's okay with that? But that's not our answer. Why is that a problem? Remember the range for sine inverse is negative pi over 2 to positive pi over 2. 11 pi over 6 is too big. So we just need to find an angle that's coterminal to this that does fall in that range. Victoria?
Do we only know that it's in those two quadrants because of like what you said earlier? I guess is sine always going to be in those two quadrants?
The output of sine inverse will be in one of those two quadrants. Unless we're giving you like, we'll talk about some other versions of this problem where we give you like more stipulations and like we might be looking for something somewhere else, but the way this one is set up where we're just asking for the exact value sine inverse cold, then yes, we're talking about just our answer having to be in those two quadrants. So how do we find an angle that's coterminal? Again, we did this in the chapter 2, I believe. So if our angle measures in radians, to find an angle coterminal to this, we're going to be adding or subtracting 2 pi. Does that ring a bell? In this case, is 11 pi over 6 too big or too small? It's too big. So should we be adding 2 pi or subtracting? Subtracting. Everybody's okay with that idea? Now, to add or subtract fractions, what do we need to have? A common denominator. In this case, where we have 11 pi over 6 minus 2 pi, the common denominator would be 6. So I'm going to think of 2 pi as 2 pi over 1. Multiply it by 6 over 6. And that gives me really 11 pi over 6 minus 12 pi over 6. When I subtract fractions, the denominator doesn't change, and I just subtract the numerators. What's 11 pi minus 12 pi? Negative 1 pi, right? And that's our answer. We can check that with our calculator by just making sure that sine of, notice I'm doing sine, not sine inverse. Sine of negative pi over 6 better give me negative 1/2. And it does. Does that feel okay so far? Victoria, you're good? Okay. So what happens now if I ask for So what if I ask us to solve sine theta equals -1/2, where theta needs to be between pi over 2 and 3 pi over 2? Well, the first thing I'm going to need to do to get that theta by itself is to do what? So I'm looking at my equation here. What do I need to do to both sides of that equation to get the theta by itself? What do I have to get rid of? The sine part. Great. What's going to cancel out sine? What have we been talking about? Sine inverse. So I'm just going to do the sine inverse to both sides. Oops. I guess that would be black. Everybody on board still? Okay. So now I'm going to go ahead and think about what I have. Based on this interval, let's say, again, let's say we want the exact value because I want to use the unit circle for this one. Okay. So looking at that range of values for theta from pi over 2 to 3 pi over 2, we're talking about those two quadrants, right? Landon? Well, my values go from pi over 2 to 3 pi over 2. So I'm talking about those two quadrants. Is that cool?
Yeah.
It's okay. It's okay. No big deal. Okay. So what I'm going to do, now that I've done that, is I'm going to go to my unit circle, and I'm going to look in quadrants 2 and 3 for the place where sine is -1/2. So again, where the y-coordinate is -1/2. That's the only place that that happens. So my answer is 7 pi over 6. Why is it okay that this answer is coming in quadrant 3? Because here we're actually solving for theta. We're solving an equation for theta. We're not just evaluating sine inverse of a number. So to solve this equation, where our answer is between these two values, we can get answers that are not inside of the range of sine inverse. We're going to use sine inverse to kind of find that value, but we can get answers that are not there. Is that okay? All right. What if we don't want an exact value at all? let's say I want to solve for theta, where sine theta is 0.55, and theta has to be between 5 pi over 2 and 7 pi over 2. So the first thing I'll do is solve my equation for theta. So I'll do the sine inverse of both sides. Everybody's so far so good there. Okay. Next, I'm going to go ahead and draw my xy axis and figure out where 5 pi over 2 to 7 pi over 2 is. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and then 7 pi over 2. Let me just make a little bit of extra space here. Is everybody okay with how I did that? Again, every 90 degrees is pi over 2 units. So I just kind of counted around by half pi's, right? So going from 5 pi over 2 to 7 pi over 2, we're talking about quadrants 2 and 3. Everybody's good with that? Now, if you remember back to chapter 2, we talked about what quadrants sine, cosine, and tangent were positive or negative in. We used that acronym, all silly turtles crawl. What that did was it's just a mnemonic to remember what quadrants sine, cosine, and tangent were positive in. A is in the first quadrant, tells us that all of sine, cosine, and tangent are positive. S is in the second quadrant. That tells us sine is positive, but cosine and tangent are negative. T is in the third quadrant, so tangent is positive, sine and cosine are negative. And C is in the fourth quadrant, cosine is positive there, sine and tangent are negative. So in our problem, if I look at this value, this is positive. So I want the place where sine is positive in between quadrants 2 and 3. Well, that's quadrant 2. Everybody's okay with that? So this is the angle theta I'm looking for. Really, I should probably be more precise. This is the angle theta that I'm looking for, right? Where we've gone around one time and then ended in that second quadrant. Is that okay? All right. So now I'm going to define another angle that I'm going to refer to as alpha. That angle is going to be made always by the terminal side of theta and the x-axis. So in our case, this is what we're talking about when we talk about this angle alpha. Everybody's good so far? Okay. What I want to do now is I'm going to relate theta, alpha, and that value on the x-axis together. So how are theta, alpha, and 3 pi related in this drawing? Well, if I go to theta, and then I go alpha more, I end up at 3 pi. Did you guys see that in the picture? If I go around theta, and then I go alpha more, I'm at 3 pi. So I can say theta plus alpha is equal to 3 pi. Is that okay? And if I subtract alpha from both sides, theta is going to be 3 pi minus alpha then. Everybody's okay with that? So what is alpha going to be? Right, we said alpha was this angle measure, which is ostensibly the value of sine in the first quadrant. So for us, alpha is going to be the sine inverse of the absolute value of 0.55. Now, do I really need the absolute value here on this case? No, but if 0.55 was negative, I definitely need that, right? So I'm going to just go to my calculator now. So I'm going to do 3 pi minus sine inverse of 0.55 so my answer should be 8.842. Radians. And I can check this. There's two things I'd want to do to check this. First, I'd want to make sure that sine of that number gives me 0.55, which it definitely does. So that's great. The second thing is I need to make sure that number is between 5 pi over 2 and 7 pi over 2. So 5 pi over 2 is 7.8, so it's certainly bigger than that. And 7 pi over 2 is 1099, so it's certainly smaller than that. So I'm positive that I have the correct answer, because that value of theta does give me 0.55 when I take the sine of it, and it falls in between the interval that I've been asked to find my answer in. This is the most complicated version of this kind of problem. So let's do a couple more examples like this. Sound okay? The previous ones were probably reasonably easy. This one's a little bit, this version gets a little bit more complicated, right? Okay. We'll do a couple more examples and then we'll just release you guys to work on this stuff so that you can kind of ask some questions and try it in real time and get some immediate feedback and stuff, okay? All right, let's say we want to do where tangent of theta is 2.50 between 7 pi and 8 pi. So here I'm using something other than sine. Nothing's really going to change in the way I'm going about doing things, right? This isn't going to change the process at all, but let's do some examples where we don't just use sine. All right, so we'll take the tangent inverse of both sides. And I'm going to skip some of the algebra there, writing all that down. You guys good with that? Okay. Then I'm going to draw my picture. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, I'm not going to write it down, 5 pi, 11 pi over 2, I'm not going to write it down, 6 pi, yeah, I don't know, whatever. This is going to be 7 pi, and then over to 8 pi. So the piece that we're looking at is one of these two quadrants. Is everybody okay there? Now, I remember that, again, all silly turtles crawl. In my situation, tangent is positive. So between quadrants 3 and 4, which quadrant is tangent positive in? Quadrant 3, because of the t. So I'll draw my angle theta. And really this angle is 2 pi, 4 pi, 6 pi, and then that's my angle theta. Everybody's okay there? And then my angle alpha is that angle, right? Always between the terminal side and the x-axis. And now I'm going to look to relate theta, the value on my x-axis, and alpha together. What's up?
Is it because it equals 7?
Well, let's look at what's going on here. If I go to 7 pi, and I go alpha more, I end up at theta. So here the equation is a little bit different, right? So it's easy to predict when you're going to be adding alpha and subtracting alpha. So let's just compare these two pictures real quick before we finish this problem off. Notice in this problem, where the last part of the axis I went through on theta was a vertical axis, and there I subtracted theta. On this problem, the last axis that theta goes through is the horizontal, and here I'm adding alpha. So that's a good way, once you've drawn your picture, you know immediately whether you're going to be adding or subtracting alpha just by which was the last part of the axis you crossed when you drew your theta. Landon?
So literally every time you pass through the vertical line that you initial vertical, you know that it's theta.
So when I draw my theta, if the last axis I pass through, so I'm drawing pass through the vertical, horizontal, vertical, horizontal, vertical, and then I'm at the end. The last one I passed through was the vertical. That tells me I'll be subtracting alpha. If the last one you passed was horizontal, you'll be adding alpha, which kind of eliminates having to like sit there and really think too hard about the picture of how you're constructing this. Sure. So when I'm drawing my theta, if the last axis I pass through is the vertical, then we're going to be subtracting alpha. If the last axis I pass through is the horizontal, we'll be adding alpha. Okay, so let's finish this up then. So alpha is always going to be just our inverse of the absolute value of our stuff. So we're just going to do 7 pi plus tan inverse of 2.5, which gives me 23.81 or 181. So to check that real quick, if I take the tangent of that value, I better get 2.5, which I do. And then just let's check to make sure that's between 7 pi and 8 pi. So it's definitely bigger than 7 pi and definitely smaller than 8 pi. So I'm sure that we have the correct answer. Okie doke. I'm going to do one more example, kind of like this, and then we're going to stop and let you guys work on some of the homework and work together and ask some questions and kind of get your hands dirty a little bit to get a hang of what's going on. Victoria, what are you trying to see?
What was the reasoning for like finding like the equation? If the circle plate, you put a 7 pi plus the alpha.
Sure. So if I just looked at the picture, if I'm just kind of following this, to here is 7 pi. And then I got to go alpha more, and that ends at theta.
No, I got that. I just don't, are we going to use that? Like, why do we even find that?
So that's how you make sure that you're finding the answer in the correct quadrant inside the correct range of values. So the problem is asking you to find theta where tangent of theta is this, and theta is in between those values. So doing it this way, that equation ensures that your value is in the correct range, and it satisfies the, that tangent of that value gives you 2.5.
Okay.
Is that?
Yeah, but we don't need it like in the last equation.
In the last equation.
Like the alpha, you could have inverse tan. Why do we even know alpha is a negative?
So, say it again one more time, Victoria.
Why do we, like, you explained like how to find if alpha is negative or positive. Why do we even know that?
Oh.
We're not going to use it like for the find the
Right. So what that is it's a shortcut to writing that equation. So that you don't have to rely on looking at the picture and figuring it out. That you can just be like, oh, the last axis I passed was the horizontal, so I'm just going to write, the x and then plus alpha or what, as opposed to having to draw the picture and like really look at it and be like, okay, is this going to be, how do I get, like it eliminates like the having to look at the picture and come up with the equation. That's what you wanted?
Yeah.
Okay, perfect. So that's a great question, right? So all I was trying to do was kind of shortcut around for you guys having to look at the picture and come up whether we're adding alpha or subtracting alpha. It just whatever crosses. You don't have to like go, okay, how are these three things related together? It just kind of makes it a little more efficient. Okay. Last example, and then I'm going to let you guys work on stuff and ask your questions and try to get a little bit done. Okay, and then I need, let's do that. Actually, let's do that. Oops. Small to big. All right. So this one's a little bit different. Well, there's really two things that I see that are kind of different than anything we've looked at to this point. One, we have a secant in here that's not sine, cosine, or tangent. What am I going to do with that? We'll describe what to do in a moment. And then two, the range of values for my theta is negatives. Right? We have negative 3 pi over 2 to negative pi over 2. We haven't seen either of those two things come up yet, so we have two kind of new things going on in this problem. Everybody's okay with that? Okay. First thing I'm going to want to do is translate secant into sine, cosine, or tangent. I remember from chapter 2 that secant is the reciprocal of cosine. So I can just rewrite this as 1 over cosine equals negative 0.87. Uh-oh, hold on one second. Let's make that negative 1.87. Sorry, I was originally going to make this a cosine problem. And then I changed it to secant because I realized I hadn't done anything like that yet. And then the number wasn't going to work out. That's not actually a value that secant can have. Okay. So this should be 1.87 there also. Okay. Everybody still okay? Sorry about that. So I need to get cosine out of the denominator and into the numerator. Everybody's okay with that? Because right now, if it's in the denominator, I can't really solve for cosine theta, or I can't solve for theta because it's in the denominator. So what I'm going to do is I'm just going to flip both sides of the equation. Everybody's okay with that? And it's okay to do that because I know that neither side is 0, right? Okay, and then I'll do cosine inverse of both sides. So that's what I'm going to be dealing with. Is everybody okay with how to get around the secant part? And if it was cosecant or cotangent, same idea, right? It's a different reciprocal, but same process. All right. Let's draw our picture then. So 0, negative pi over 2, negative pi, and negative 3 pi over 2. So we're talking about from negative pi over 2 to negative 3 pi over 2 is quadrants 2 and 3. So all silly turtles crawl. The place that I'm looking for it is where cosine is negative. Oh, fiddlesticks. Yeah, let's just change the problem here a little bit. Make this negative pi to negative 2 pi. My apologies, guys. Eek. Okay, so going negative pi to negative 2 pi is there. That's better. And where is cosine negative? In the third quadrant. Oh my goodness, guys. Okay. All right. If I made a big enough mess out of this, it's not the third quadrant because I did the wrong thing here. Okay. All right. Let me just get this squared away. Okay. I'm just going to start all the way over again because I've made enough of a mess out of this. All right. 0. Negative pi over 2. Negative pi. Negative 3 pi over 2. Negative 2 pi. So remember, we're going the opposite way because these are negative angle measures. So going from negative pi to negative 2 pi is quadrants 1 and 2. Alex, what's up? Yes, go ahead. Cosine is negative in the second quadrant then, yes. Sorry about that. Everybody's cool? Okay. I changed some stuff and then I tried to just pick up where I left off and I made a mistake and so there's my theta. Everybody's still doing all right. Okay. So here I'm going to say theta is equal to negative pi. And normally we would say plus alpha, right? Since the last axis we crossed was a horizontal. The problem is when we're going the opposite direction, it's the opposite. So it's going to be minus in this time. Does everybody catch that? So normally, if you're going forward, and this situation happened where you're crossing horizontal last, you'd be subtracting, or adding. Because we're going backwards, everything is reversed. Is that okay? I know, there's a lot of little, details going on here, right? We're doing things for geometric reasons, not algebraic reasons, and that gets hard to handle all of that. Okay, but we're good now. So if we go to the calculator, do negative pi minus cosine inverse. Now remember, this is going to be the absolute value of negative 1 over 1.87. So I'm not going to bother to do the absolute value in my calculator because I can make something positive in my head without having to push the buttons on my calculator, but I want to point out that this is a positive value always for alpha. So I got negative 4.184. Let's just check that real quick. So if I do 1 over cosine of that value, I better get negative 187, which I do. And then I should make sure that this number is less than negative pi. Oh boy, that's a problem too. Okay. So it needs to be in between negative 2 pi, where it's bigger than that number, and less than negative pi, and it's smaller than that number. So we're good. As a yet another mistake I made here, really the 2 pi should be on that side and the 1 pi should be on that side. It didn't make a lot of sense for the bigger number to be less than the smaller number. Boy, oh boy, Kulik. Maria. Of course, sure. Okay, we're going to stop here. This was a lot. I will